Okay, so that's the end of that page. Next page. Express y equals 2x squared plus 4x minus 3 in turning point form. I know a losing battle when I see one, but nevertheless, because I'm stubborn, I really just want to prosecute the case. I am confident that the reason why people don't do it this way is because their teachers tell them differently. But I know there's people I taught last year that still do it differently to me, so maybe I need to give up. But nevertheless, I just want to show you that this is the methodology I strongly encourage you to use because it has fewer fractions as you work it out in many cases. So in the case of this one here, the difference between me and other teachers, and if they watch this video, they'll probably eye roll right now, is that when I take out a common factor, I only take out the coefficient of x squared, that's normal, but I only take it out of the first two terms. Now, what many of you did was you factorized out across the whole expression, and I can see why that would give you comfort, but ultimately what you end up with is, of course, y equals 2 outside of x squared plus x, was it plus? 3 over 2. Minus, thank you. Plus 2x as well, and a minus. Okay, apart from me stuffing it up. Minus 2x and minus 3 over 2. Man. Plus 2x minus 3 over 2. Okay, so that's what you end up with. You end up with a nasty old fraction there, which you then have to keep until you expand it again. So the next line is 2 outside of x plus 1 all squared minus 1 squared minus 3 over 2. And then you have to make sure that you're converting in your head okay. So minus 1 is minus 2 over 2, and minus 2 over 2 minus 3 over 2 is minus 5 over 2. So you've got that. Oops, ignore that square there. And then when you expand out, you just get at the end of it the minus 5 as you would expect. Okay? It works, it's fine, and like 90% of the students did it this way because this is my only time. I'm going to shut up about it from now on because there's nothing wrong with it. I just think it's not as tidy or efficient as just factorizing out the first two terms only. So you factor the 2 out and you get x squared minus 2x, and the minus 3 just hangs there like a dag off a sheep, right? So we just do that. Then I do my completing the square of the inside, which is effectively just, because there's no term there, it's just effectively, use your usual x minus 1 all squared, take away 1 squared, done, close the square bracket, then expand through, and you can see there's no fraction work involved here at all. I reckon it's better. You may disagree. I just realised what I've done here, so it doesn't matter. The solutions were definitely right as I went along. I just forgot to correct my solution here. So this should have been an x squared plus 2x there, x plus 1 plus 1 plus 1. So the answer should be x plus 1 all squared minus 5, and you can see that my turning point is right here as well. Okay, please feel free to ask me questions about that now, but again, you don't have to argue with me. If you want to keep doing it the way you've done it, that's fine. You do it, you do it the worst way, that's fine. No worries. Any questions? Okay, that was just me being tongue-in-cheek there. So the minimum point for the function, that's, do you remember what minimum point means, turning point? The answer is everyone does. You might notice in your tests, you might in this section got a lot of ECFs. So ECF means error carried forward. Okay, so if you made an error up here, but your turning point was right according to your error, then you get the mark. Guys, if the turning point was wrong according to what you wrote up here, you'd still lose the mark. Okay, so the error is carried forward and you get it right and wrong based upon your error carried forward. Most people were okay with that though. Now, this bit here I felt was a particular weakness of heaps of people. Remember I marked all 3 classes. when you're doing these, a number of people try to do what I've got here in the OR box here, which is they try to transform the function. If you I've got a mistake. That should be a 5 there. If you transform the function, you will 100% get the right turning point. Okay, that's absolutely fine, but it is a bit more work in your head. You should be able to take the transformations given, and apply them directly to points that you're given. In this case, you've got a turning point here, so use that turning point and transform it. Generally speaking, it's actually a lot easier. So it's translated 4 units to the left. Okay, so my -1 becomes a -5 because it's gone 4 units to the left. Okay, my -5 here stays the same because this was a transformation of the x, not a transformation of the y. Reflected in the x-axis. So in the next direction, in the next one here, my -5 stayed the same. In the x-axis means it's a flip, a vertical flip. So the -5 now becomes a +5. So that's that done. And then the last one translated 2 units up. So my 5 then becomes a 7. Order is important, and you just transform the point. Once you've transformed the point, give the equation of the new function. You don't have to do this at all. You just simply say, well, I know that it was dilated by 2 vertically. That hasn't changed. So it's going to be the same as this, except that should be a plus. It's going to be the same as that, except it's going to have a reflection. And I now know my new turning point. It's -5, 7, so it'll be x +5 and a +7 there. That's it. 1 mark for remembering that there's a reflection. Half a mark because all you had to do was transfer it from here. You did not need to do this at all. Okay. A couple of you did this. You expanded it. You do not need to do that either. Leaving it in turning point form is 100% acceptable. And that's it for that one. Anyone got any questions? Okay. We modified this question between the draft and the actual. That's why it looks a bit different here. Expand and simplify 2 minus x to the power of 4. That's the way to do it. Done. Easy as. What I noticed that some people did, there's nothing wrong with it. Again, nothing wrong with it. But some people chose to order it from the highest power of x. I feel like that might be something a teacher has told you to do, to always write it in descending powers of x. It depends on the context, right? But for a straightforward expansion, you don't have to reorder it. Don't waste time. Just write it in the order it comes. You don't have to reorder it. A lot of people decided that they would write it as -x. I can't write it very well. -x plus 2 to the power of 4 first. So you've skipped it around for the -x to be at the top, and then you've done it. Don't bother. I mean, do it if you want to, whatever floats your boat. But it's really a pointless step, and it worries me that it makes you think that you have to have the term with an x in it first. Okay, and you don't. And then what are you going to do if the expansion that you've got ends up being x plus 1 on x to the power of 4? What are you going to put first? I don't know. And you've got x in both places now. Oh, no. So, think about it. Think about the expansion. Think about what you're doing. Don't waste time by reordering it unless it's important for the context, like it tells you, and express in descending powers of x, or it's a function and you think, I better put the leading term first. There might be good reasons for doing it, but there's also good reasons for not doing it. This is a straight expansion, so that's it. Okay, I'm going to pause the video for a tick, and I might stop the video there.